Hi, tutor. So I have this question for homework, and it says that Daniel traveled 180 kilometers to attend an event. He had to slow down by 15 kilometers per hour on the way back because of road construction. So that added 2 hours to the trip. And how quickly did he travel to the conference?
Awesome. Great question, Annie. Word problems can be tricky, so we'll go through this one nice and slow.
Yes.
Let's start kind of drawing this out and organizing the information in the question. So Daniel's traveling to an event. We know that the distance is equal to 180 kilometers. Because it's a word problem, we'll try to keep track of our units a little more carefully. 180 kilometers. But that's all the information we know on the way there, right?
Mm-hmm.
We know on the way back, we know that he had to slow down, so his speed is equal to 15 kilometers an hour slower than what he traveled on the way there.
Yes.
So we don't know his speed going to the event, so we'll
Mm-hmm.
leave this as a variable. And I'm going to put ones over here to help us distinguish between information going there versus coming back.
Okay.
So we're just going to leave this as a variable. We'll say that his speed on the way there is just S1.
Mm-hmm.
How can we relate his speed coming back, S2? How do we relate it to this variable here?
So for this one, we can have it's the speed, and then we know that there's a slowdown, so that'd be a minus.
Minus,
So
yeah.
maybe S1 minus 15.
Awesome. Yeah, great job. So whatever speed was on the way going to event, we're going to subtract 15 kilometers an hour. Nice. You got the units there. Let me write it here. We're going to subtract 15 to figure out how fast he was going on the way home. And the reason why this is important is to kind of like relate it in terms of this other variable is because you're going to find that we have lots and lots of variables, but for every variable you have, you need an equation to be able to solve it.
Yes.
So by writing S2 as S1 minus 15, we don't have to worry about S2 anymore. We can just think of it in terms of S1.
Mm.
Perfect. And it also says on the way back, it added 2 hours to the trip. So what is T2 going to be?
So added 2 hours, that would be an addition one. So it'd be T1 representing the first time. And then we're going to add 2 hours.
Perfect. And so on the way there, we don't know the time, so we're just going to call it T1.
Yes.
So this is good. On the way there, we know the distance, the speed, and the time.
Mm-hmm.
On the way home, we know the speed and the time. What is the distance?
The distance will be the same because there's no difference in the length of his travel between the to the
Exactly.
event.
Yeah. So we're making a little bit of an assumption. Even though there was construction, we assume that
Mm-hmm.
they take the same route. So it took 180 kilometers to get there, and it's going to take 180 to get back.
And 180 here. Okay.
Perfect. Awesome. So now we know the speed, the distance, and the time going there and going back. We've got a lot of unknowns, but really we just have, let me mark them. We need to solve for S1 because that will help us solve for S2. And we need to solve for T1, which will help solve T2.
Mm-hmm.
So even though there's a lot of variables written down here, we really just need to solve for two of them, S1 and T1.
Mm-hmm.
But in order to do that, we're going to need some equations. So
Okay.
can you think of any equations that you know that relate speed, distance, and time all together?
Yes. So there'd be the distance,
Mhm.
speed over time formula.
Equals speed over time. And
Right.
if you look at the units here, speed is kilometers divided by hours,
Mhm.
and then time is hours. So what would happen? Yeah. Oh, sorry, I
Oh,
thought I interrupted you.
no, no, no. So the hours, since it's kilometers over hours,
Mhm.
and then the hours would, I should wait, just since it would be multiplying.
Yeah, let's work it out. So kilometers per hour divided by hours, which is like multiplying
Mm.
by 1 over hours. So it's not canceling out here. So yeah,
So I
double
would need to multiply them together.
multiply them. Yeah,
Let me change this one.
awesome. Yeah, so it really helped that
Anything
we wrote,
time.
yeah, it really helped that we wrote the units.
Mhm.
So we have distance is equal to the speed multiplied by the time, and that should make a bit of sense intuitively as well. So let's say you're traveling 10 kilometers an hour, and you do that for 1 hour, you multiply those numbers to find your distance. Perfect. And I'm just going to add one little thing here because we're going to have the same equation on this side. Distance is equal to speed times time. So I'm going to put a little 1 over here and a little 2 because it's going to be the speed on the way coming home multiplied by the time on the way coming home is equal to 180. And then same thing over here with the initial information. Awesome. So let's plug in everything we know into these two equations. So let's start over here on the left. My board keeps moving around, sorry.
So here we will fill in distance, which will be 180 kilometers. S1 and T1 will stay the same.
Exactly. Those are unknowns. So we don't know them.
And for this side, we will have 180 will be equal to S, put in brackets, 15 times T1 plus 2.
Plus 2. Awesome. And yeah, I'm okay if we omit the units when we're working with the equations. We'll add them back at the end.
Okay.
Awesome. So right now we've got two equations with two unknowns. So that's good. We should be able to solve for them individually. Do you remember the two different techniques that you can that you can use to solve a system of equations?
So for this one, maybe we can use the quadratic formula.
Quadratic formula will help us eventually. But if you have two equations and two unknowns, there's two different strategies that you can use to solve for them. One of them is called substitution. Do you remember
Yeah.
that?
Yes.
Do you remember what the other one is?
We can also cancel it out.
Yeah, using elimination.
Yes.
So typically, typically for elimination, you would want like all the variables to line up nicely. This one's actually a little more complicated, so I think substitution is going to be helpful here.
Okay.
There's a couple different ways we can do this. Do you have a preference? How would you solve this question if you had these two equations?
To substitute, I would use this one to substitute into this one because this one is shorter and easier to work with when substituting in.
Okay, so substitute something from this equation into that one.
Yes.
And what would you substitute?
I would substitute maybe the speed first.
The speed? Yeah, great.
Mhm.
You might notice that both these equations are actually equal to 180.
Yes.
So technically, you could put speed 1 times time 1 and put it right here. But the reason why you don't want to do that is because it doesn't get rid of any variables. The whole
Oh,
point, yeah, the whole point of substitution is so that you get rid of one of your variables and you're left with one equation with one unknown that you can solve for.
oh, okay, got it.
Yeah, so we won't do that. And instead, I think you suggested substituting for speed one.
Yes.
Cool. So if we want to substitute for speed one, what do we have to do on this left equation first?
We will have to isolate the
Yeah,
speed
exactly.
one.
You want to
So,
give that a try?
yep. So speed one. I will take the t over to this side,
Yeah,
and it'd be 180 over t1.
perfect. And then what do we do? What do we do with that equation?
We will put this one into this equation here. So what will
Exactly.
happen is we will have 180
Mhm.
equals 2, substituting S1 over T1,
Mhm.
subtracting 15 gives me T1 plus 2.
Awesome job. So you took this S1, we know it's equal to 180 over T1, and you can just plug it in over here, and doing so eliminates this S1 variable. If you look down here, this equation only has T1, which is going to be
Yes.
good because we're going to be solving for it.
Okay.
Do you want to take a stab at the next step?
So the next step, we can maybe expand it.
Do you want to describe that step before you write it out?
Okay, sure. So what I can do is I can do FOIL. So this one
Well,
will multiply into this one, and then this one can multiply this one, and then this one with the 2 backwards.
yeah, that's right. Before you do that, I would actually suggest maybe dealing with this T1 in the denominator. It can be a little tricky working with it down there. So imagine you're going to do 180 over T1 multiplied by T1 when you do FOIL. That one's going to be nice and easy because the T1s actually cancel out.
Yes.
But when you do it over here, you're still going to have a T1 in the denominator.
Mm-hmm.
So you're going to have a bunch of different terms. You're going to have T1 in the numerator and T1 in the denominator.
Yes.
I would prefer, sorry, erasing stuff here. I would prefer if we dealt with this T1 first by creating a common denominator in this term. Do you remember what a common denominator is?
Yes. So multiplying it so that the 2 have the same denominator.
Yeah, and what is that common denominator in this case?
Uh, the common denominator in this case will be t, 2t.
Yeah, it's just the T1 here. So you can think of the 15 as having a denominator of 1. So the common denominator between 180 over T1 and 15 over 1 is T1. So we want to get both of them over T1. The 180 is already over T1, so you can leave it by itself. But what do we have to do to this number over here to have a numerator and denominator of T1?
I would have to multiply it
Exactly,
with
yeah.
t1.
So you can think of this as like multiplying the top and the bottom by T1. So now the denominator is T1, and we've got that down here. What would the new numerator be?
The new numerator will be 15t1.
Yeah, 15 T1. Awesome. Now you might be thinking to yourself, but we still have a T1 in the denominator. How do we deal with that? Because this is all multiplication and division, you can think of the T1 as a division, and we can move the T1 up to the other side. So I'm going to take the T1 from this fraction, and I'm going to bring it up here. And the reason I can do that is because you can think of this as the numerator being in brackets divided by a single term in the denominator.
Oh,
And remember,
okay.
multiplication and division, you can switch up the order. It doesn't matter how you do
Yes.
them. Awesome. So this will be 180t. I'm going to drop the 1 for now. No, let's just write it. This is going to be 180 minus 15 and t plus 2. And now you can see we don't have that t1 in the denominator anymore. And that's going to make our foiling a lot easier.
Mm.
Okay, do you want to take a stab at foiling?
Okay, sure. So the A180 can multiply to the t. So I get 180t. And then the 180 can multiply with the 2. So I would get 180 times 2. So I would get 3. Maybe let me erase that. 360 minus 15 times 2. 15t give me this, and then I have 2 times 15t will give me 30t.
30t, awesome. So just to verify,
Just,
1, yeah.
Put it back in brackets. I don't think I need.
No, you can get rid of the brackets when you foil.
Let me.
Yeah, awesome. And then do you want to fill out the left side while I verify? So 180 times t1, that looks good. 180 times 2 is 360. Negative 15t1 times t1 is negative 15t1 squared. And negative 15t times 2 is negative 30t. Awesome. I'll put the ones here just so we don't forget. But yeah, if you want to drop the 1, and then you just got to remember at the end to put it back. Okay, so this is a quadratic equation because we have t1 squared. So let's get everything onto one side and have it set equal to 0.
0 here. If we bring the 180 over to this side, it will cancel out.
Perfect, yeah.
So I can omit that one, and then writing it in.
Awesome. I like how you put it in order. So you've got the t squared first, and all of your plus and minuses look good as well.
Okay, thank you.
So we have a quadratic equation with respect to t1. We could try to maybe yeah, we could use a quadratic equation, but the numbers might actually work out here. So can you think of a way to simplify this before we try to factor it?
We can simplify it by dividing them by a common number, common
Yeah,
factor.
exactly. Yeah. So what can we common factor out?
Maybe the negative 15.
Perfect. Yeah. When you do that, yeah, let's write it out.
So negative 15, this would be t2. And then this would be plus 2. And then for this one, this will be.
You can use a calculator for that. 360 divided by 15 is 24.
Thank you. 20. Wait, this will be a negative.
Negative. Awesome. Yeah. So don't hesitate to do something like this just to help you remember. Nice. So now we have a quadratic equation. The number's actually pretty good. Let's try to factor this. If you're trying to factor it, you're thinking of two numbers that multiply to what?
Two numbers that multiply to 24.
Positive or negative?
With it be, one could be positive and one could be negative.
Yeah, so those should multiply to negative 24, and those same numbers have to add to,
2.
yeah, to 2. Okay, I'll give you a second to try to figure it out.
If I try 2 times 12,
Mm-hmm.
if I have either negative 2 and negative 2 with 12 will give me 10.
Yeah.
And if I have 2 and negative 12, it will give me negative 10. So I know that one doesn't work.
Yeah.
I can cross this out. Maybe if I try 3 and 8, 3 and 8, if I have a negative 3, then my 8 will be a 5. Then that wouldn't make sense with this one. If I have a negative 8 and a positive 3, it also would not give me 2. So I can cross out this one. And then I can try 4 and 6. 4 and 6, I can do negative 4. And then what will happen is my 6 would times negative 4, giving me negative 24. And then 6 subtract 4 will give me 2, and it would work.
Awesome. Yeah, great. Yeah, I'll let you write that in.
Okay.
So one of the tricks that I use is if they have to multiply to a negative number, but add to a positive, you know one of the numbers has to be negative because when you multiply a positive and a negative, you get negative.
Yes.
If they have to add to a positive number, then that means the positive, like the bigger number has to be positive.
Yes.
So the 6 being positive here makes lots of sense. Awesome job. So do you want to factor that for me?
Sure. I have negative 4 t, and then plus 6.
You remember, so when you have a quadratic equation and you go to factor it, remember you set up like 2 different brackets?
Oh, yes. Wait, let me retry this. Oh, it's not erasing.
Is it being finicky?
Yes. Okay, thank you.
Yeah.
I remember now. This is T1, and then I need to subtract 4 with T1 plus 6.
Perfect. So we factor this equation, and then somehow this will help us solve for the answer of T1.
Yes. And I can isolate for T. So it would be T1 will give me 4.
Yeah.
And then T1 can also give me negative 6.
Awesome. So we have 2 answers. Are they both valid?
No. So for t equals negative 6, this one is not valid because time cannot be in negative form. So we can omit this one and then keep t1 equals 4.
Perfect. And before we talk about that answer, do you know why you can split this up and just solve them kind of individually? Because like basically you solve this one and then you solve that one by itself. But do you know why you can do that?
Maybe because this one, and because in a quadratic formula there are 2 points that cross through 0 on the y line, so then there is 2 points I could find.
Yeah, that's very possible. Sometimes though with a quadratic, you can have scenarios like this where it only has one solution, or scenarios like this where it actually has 0 solutions. But the reason why you can split this up from like an algebra perspective is because you have 2 terms that are being multiplied together.
Yes.
If either one of those terms is 0, the whole answer will be 0.
Mm.
So that's why you can solve for each term individually. When t1 is equal to 4, this first term is equal to 0. So it doesn't matter what's happening on the other term. 0 times anything is just going to be 0.
Yeah.
That's why we can split it up.
Oh, okay, I see.
Nice. Okay, so we got t1 equals to 4. I'm going to scroll all the way back. This is a long question. Okay, let's go up here. So let's use a different color. We've got t1 is equal to 4 hours. What does that tell us about t2?
T2 will equal to 6 hours.
6 hours. Awesome. And if we know the distance is 180 and the time is 4, what is speed 1?
So we can find speed. We can substitute it into the distance speed time formula.
Exactly.
And
So
then
basically
find
this
S.
one. Yeah. So basically this one here, because you're already
Yeah.
isolated.
So I can take 180 divided by 4.
Yeah.
Like here, I will get and then solving that, it would be 45.
Yeah, 45.
And then speed is in kilometers per hour.
Perfect. So 45 kilometers an hour. Let's write that up here. So on the way there, 45 kilometers per hour. It took 4 hours. On the way back, traveling the same distance, took a little bit longer, 6 hours. What speed did they travel on the way back?
So for this one, I would have to subtract 15 from here. So I would have 45, take away 15, giving me 30.
30, yeah. So 30 kilometers an hour times 6 hours gives you the 180 kilometers. 45 kilometers an hour times 4 hours also gives you 180 kilometers per hour. And what was the question? What were we trying to answer?
It asked how quickly did he travel to the conference.
Awesome.
So we're looking for the speed.
For the speed, yeah. So for
the
a word
initial
problem,
speed.
Yeah, for a word problem, I would recommend maybe like write a sentence. So say like his speed traveling to the conference was, and we've got our units here. So you're set up. Awesome, great job. That was a long question.
Thank you.
Anything that I can better clarify?
I think it's pretty good. It was very easy for me to take in. Thank you.
Awesome. Yeah, you're very welcome. Keep practicing. You're doing a great job.
Thank you.